Hello fellas, welcome back. Hopefully you guys got a good understanding of the elimination method, did some practice problems and really feel comfortable with it. Purpose of this video is we're going to start by again looking at some word problems to incorporate some of these ideas and also just to work on problem solving skills. Then we're going to look at a couple examples where we have to determine whether to use the elimination method or to use the substitution method, and then proceed through those couple examples. All right, should be a shorter video, so hopefully give you guys some time to get some more practice. All right, but let's get started. I do want to talk about one thing, and it's the interpretation of our solutions. Okay, and so in some of your reading, you guys will see that we talk about different types of solutions, and one of them is a consistent solution. A linear system of equations is consistent if it has at least one solution. In other words, if those two lines at least either intersect, in which case I'd have one solution, or if they are the identical line, okay, then they would be called a consistent solution. All right. If a consistent system has one solution, in other words, if it intersects at one point, then we say the system is independent. If it has infinitely many solutions, in other words, if it's the same line, we say that it's a dependent solution. And if there's no solution, if I have parallel lines, I say the system is called inconsistent. Okay, just some terminology that you guys should be aware of. Should be pretty straightforward. Okay, but if I have a system of equations, one of three things is going to happen. They're going to intersect at one point. The system is going to be the same line, describe the exact same line, or the lines are going to be parallel. All right. Let's look at a couple word problems. Two planes start from LA International Airport and fly in opposite directions. The second plane leaves 30 minutes after the first plane, but its speed is 80 kilometers per hour faster than the first. Find the airspeed of each plane if 2 hours after the first plane departs, the planes are 3,200 kilometers apart. Sounds like a lot of words. Again, you guys have to be able to break this stuff down in order to make sense of it. But, if I think about this, if I have one plane is going to fly in one direction, we have one plane flying this way, and we have one flying this way. I basically want to set up an equation that describes the distance between them. Okay? So if I let v1 be the speed of the first plane and v2 be the speed of the second plane, we can think about the distance when they're going to be 3,200 kilometers apart. Okay, the distance is going to be the speed of the first. The first plane flies for 2 hours. Okay, how do I know that? If after 2 hours, right here. All right, the distance that the first plane travels in 2 hours is its speed times the 2 hours. All right, since they are going in opposite directions, I want to add how far each of them travel. So I'm going to have the second plane, who only travels for an hour and a half, times v2 is got to equal 3,200 kilometers. In other words, if I think about this graphically, if we started right here, and this is v2, and this is v1, okay, plane 1 and plane 2, 2 is over here. The distance it traveled is v2 times 1.5. The distance this guy traveled here is v1 times 2 hours. And what I want is this total distance here, okay, is going to be equal to 3,200 kilometers. Okay, so there's a visual of what's going on. All right, right now the problem is I have one equation, but I have two unknowns here, so I have to find something else that relates v1 and v2. Well, that comes by the fact that v2 is 80 kilometers per hour faster than v1. So I write it like that. Okay. At this point, what I can do is this is all set up for the substitution method, that I can plug this part right into there. Okay. If I do that, this is what I get. I get 2v1 plus 1.5 v1 plus 80. Again, now I have an equation with just one variable in it, which I can solve. And if I do that, I get v1 is equal to 880 kilometers per hour. Now I can back solve and find v2, and what you should see is that v2 is equal to 960 kilometers because I'm going to plug this right into there. Okay? So another example, a little bit more challenging here. A total of $3,200 is invested in two municipal bonds that pay 5.75% and 6.25% simple interest. The investor wants an annual interest income of $1,900 from his investments. What amount should be invested in the 5.75% bond? Okay, again, a lot of words, have to break it down. Keywords, total investments $3,200. I'm going to put some in this one and some in this one, but I know what my outcome is. I want a total amount of interest to be $1,900. Okay? Let X be the amount invested in the 5.75% bond. If I do that, what is the amount that's going to be invested in the 6.25% bond? Well, that's going to be the $3,200 minus whatever I invested in this bond, minus X. Okay? Again, make sure you guys are walking through this with me. If I do that, let's think about how much interest I'm going to earn. All right? If I do that, the interest income I'm going to earn is 0.0575. Again, I got to take my percentage and put it into decimal form, times X, okay, plus the amount that I put in the 6.25% bond times the 0.0625. And that has to equal 1,900. Again, this is the interest from this bond right there. This part is getting me the interest from this one right there. And I know that the total interest income has to equal 1,900 as stated right there. Now I have an equation of one unknown. I can combine like terms, and I can solve for X. X is $20,000. That means I want to invest $20,000 in the 5.75% bond, which means that if I back substitute, plug this into there, I should see that I got to invest $12,000 in the 6.25% bond. Okay? Let's look at determining whether or not we should use substitution or elimination in a couple examples here. Here's an example: 7x plus 3y equals 16, and x minus y is equal to -2. Personally, at this point, I'm thinking about solving this for x, this second equation. So I'm going to do this one with substitution. It's rather easy. If I do that, if I solve 2 for x, I'm going to get x is equal to y minus 2. And now what I'm going to do is I'm going to take this value right here and plug it in wherever I see an x in the first equation, which is right there. Okay, if I do that, I get 7 times y minus 2 plus 3y. Combine my terms, I'll get 10y is equal to 30. So y is going to be equal to 3. Back substitute to solve for x. Okay, I would take this value of y, put it over there. You see that I'm going to get x is equal to 1. Check my solutions. Works. So the solution to this system is 1, 3. Could I have done this with elimination? Absolutely. Probably would have multiplied this bottom equation, number 2, by 3, and then gone from there. This is a system right here. 4x minus 3y is equal to 6. Minus 5x plus 7y is equal to -1. Looking at this one, substitution would be more difficult here. So what I'm going to do is I'm going to use elimination. I already have opposite signs on my x's. I'm going to multiply the top one by 5, the bottom one by 4. Okay, so multiply 1 by 5 and 2 by 4. If I do that, I get 20x minus 15y equals 30. Again, remember, I got to multiply the entire equation by 5. And then the second equation, the entire equation by 4. Negative 20x plus 28y equals -4. Now I can add these, and the x terms are going to go away. 13y is equal to 26. Divide by 13. I get y is equal to 2. Again, we have to back substitute to solve for x. Again, it doesn't matter which equation I use. 4x minus 3 times 2 is equal to 6. I get x is equal to 3. Check my solutions. They work out. And so I have the point 3, 2 is a solution. Again, in the linear line, this is going to be the intersection point. I would say that this system is consistent based upon what we talked about earlier, and independent. Remember, consistent solution means that I have at least one solution. A system is consistent if it has at least one solution. If it has exactly one solution, we say it's independent. So this would be an independent, consistent system of equations. All right. I want you to read these pages here. Look at these examples right there. Here's some more practice problems. I'm going to do one more video. We're actually going to step it up a little bit. We're going to do 3 equations with 3 unknowns. We'll learn how to do that. Again, it's just a little bit more work, but the same idea. Okay. Make sure you guys are practicing this. Attending the Hangout sessions if you're having some difficulties, or shoot me off some emails. Okay, fellas? Have a good day.